Hi everyone. In this session, we are going to see about the electrical analogous. That is, we are going to convert the mechanical system in terms of the electrical system here. Here, we are going to see about the mechanical translation system to a electrical system. So, we are going to calculate the force voltage analog and current analog here. In the previous session, we have seen about the mechanical translation systems and mechanical rotational system, everything. Okay, now we are going to see about the electrical system now. Most of the electrical system can be modeled by the three basic elements, that is a resistor, inductor and a capacitors. Circuits consist of these three elements are analyzed by using the Kirchhoff law and the current law. Here, a resistor circuit is shown here. The mathematical model is given by the Ohm's law relationship, that is V is equal to IR. V in terms of T. V of T equal I of T divided by I of T into R. That is, in terms of we are going to calculate the current, then it will be I of T is equal V of T divided by R. The circuit representing the inductance is shown here, and for this we are using the input output relationships are given by the Faraday law. So V of t is equal L into di of t divided by dt. For current, I of t is equal 1 by L into integral of V dt, where integral of V dt is known as the flux linkage. Thus, I of t is equal flux of t divided by L. The circuit of the capacitor is shown here, and we are going to calculate the voltage and current value from this. So V of t is equal 1 divided by C into integral of I of dt, and I of t is equal C into dV divided by dt. Uh, from this, we know that charge will be calculated as q is equal integral of I into dt. Therefore, V of t is equal q of t divided by C. First, we are going to know the force voltage analogous, that is, mechanical systems will be converted into electrical systems. In terms, we are going to change the value of force in terms of electrical as voltage, and mass in terms of electrical as inductance, in friction coefficient in terms of resistance, spring constant in terms of an electrical system as a reciprocal of a capacitance, and a displacement in terms of electrical system as a charge q, and velocity v in terms of electrical system as current I. Next one is the force current analog system. Here the force will be converted into current I, and the mass is converted into a capacitance C, and the frictional coefficient is converted into a reciprocal of a resistance, and a spring constant K in terms of a reciprocal of a inductance 1 divided by L, and the displacement X will be converted into a magnetic flux, and the velocity v is converted into the voltage v. Now we are going to solve a problems using these values, these conversions. We are going to solve the mechanical system to a electrical system. First problem, we are going to find the force current electrical analogous circuit through this circuit. Okay, so here we are having mass 1 and mass 2. First we are going to write the free body diagram. Using that free body diagram, we are going to construct the differential equation for this. After finding a differential equation, we are going to convert the value in terms of displacement to a velocity. After that, we are going to change the mechanical system, that is a mechanical elements to an electrical element. By the tabular column, we have by the consideration of the previous tabular column we have discussed before this. Okay, First, we are going to write the free body diagram for a mass 1. For that, a force applied on the mass 1 will be F of M1, F of B1 and F of K1, and the displacement here is x1. So, we are going to calculate the differential equation now. We are going to write the differential equation from this, that is m1 into d square x1 divided by dt square plus b1 into dx1 minus of x2 divided by dt plus k1 into x1 minus of x2, because here friction B and the spring K is connected between the two masses, that is mass 1 and mass 2. Now we are writing the equation for mass 1. So we have considering the x1 as first term and x2 as the second term. So x1 minus of x2 we are writing here. For the mass 2, we are writing the differential equation, that is based on the force acting and acting on it and the applied force. Here for mass 2, we are having the applied force as F of t, and we are having the friction B2 and K2. After that, we are the mass 2 is connected with the K1 and the B1. So we are going to write the equation, differential equation for this, that is f m2 into d square x2 divided by dt square plus b1 into d into x2 minus of x1 divided by dt plus b2 into dx2 divided by dt plus k1 into x2 minus of x1 plus k2 into x2 equal f of t. For a force current analogous circuit, first we are have to change that values in terms of velocity, that is displacement in terms of velocity. So for that we have to mention the values as m1 into dv divided by dt, that is dv1 divided by dt plus b1 into v1 plus k1 into integral of v1 minus of v2 we have to write here. And for the equation 2 we have to write as m2 into dv2 divided by dt plus b1 into v1 v2 minus of v1 b2 into v2 plus k1 into integral of v2 minus of v1 dt plus k2 into integral of v2 into dt equal f of t. Now we are going to change the value of v as v1, that is a velocity as a voltage here, and for mass we are considering as a capacitor, for a friction we are considering as the reciprocal of the resistance, and the spring we are going to calculate as a reciprocal of the inductance. Thus the system equations are C1 of d1 divided by dt plus 1 divided by r1 into v1 minus of v2 plus 1 divided by l1 into v1 minus of v2 dt equals 0. C2 into dv2 divided by dt plus 1 by r2 into v2 plus 1 divided by l2 into integral of v2 dt plus 1 divided by r1 into v2 minus of v1 plus 1 divided by L1 into integral of V2 minus of V1 dt equal I of t. Okay, we have find the equation of an electrical system. Now we are going to construct a circuit using these equation. Okay, from this we have to, if for a force current analogous system, we have to use the node values, that is we are going to draw the diagram using the nodal equations, that is for we have to consider the v1 as first node and v2 as the second node. In between v1 and v2 we have to connect the common values of v1 and v2, that the common values of v1 and v2 is l1 and the r1. So we have to connect that in a parallel parallel form. Okay, parallel form. Then we have to connect that between the node 1, that is v1, and the node 2 as v2 here. After that, for a v1 only, we are having the value as capacitance, so we have to draw a capacitance in the first node. In for a second node, we are having many values, that is first value, that is I of t is here. So everything will be connected in terms of in the form of a parallel only. For a nodal equation, everything will be connected in parallel manner, so we have to calculate the other values, that is belongs to a v2, that will be connected in a parallel manner here, that is I of t and C2 and R2 and L2. Okay. In the next sum, we will see about the force voltage and force current analogous system. Okay. The second sums given as write the differential equation governing the mechanical system shown in figure. Draw the force voltage and force current electrical analogous system and verify by writing the mesh and the node equation. Okay, we know that how to write the equations first. That is, a differential equation is written from the um, free body diagram of a mass 1 and a mass 2. So we directly write the equation as m1 into d square x1 divided by dt square plus b1 into dx divided by dt plus b12 into d divided by dt into x1 minus of x2 plus k1 into x1 minus of x2 equals 0, because there is no applied force in the mass 1, so we are considering as 0 here. For a mass 2, we are going to write the differential equation as m2 into d square x divided by dt square plus b2 into dx2 divided by dt plus b1 of t into d divided by dt x2 minus of x1 plus k2 into x2 plus k1 into x2 minus of x1 equals 0. Replacing the displacement by velocity in the differential equation, we get d square x divided by dt square as dv divided by dt and dx divided by dt as v, and x is equal to integral of v into dt. m1 into d square v1 divided by dt square plus b1 v1 plus b12 into v1 minus of v2 plus integral of k1 into v1 minus of v2 dt equal f of t. m2 into d square v2 divided by dt square plus b2 v2 plus b12 into v2 minus of v1 plus integral of k2 into v2 minus of v1 dt equal 0. For a force voltage analogous system, the electrical analogous element for the element of a mechanical system is given by force f of t is equal to E of t and v1 equal I1, m1 equal L1 and b equal R1 and k is equal 1 by c. That is, force is in terms of a voltage, that is v of t, and the velocity v1 is in terms of current I, and the mass will be in terms of inductance, and the friction will be in terms of the resistance, and the spring will be in terms of the reciprocal of the capacitance. The mesh based equation using the Kirchhoff voltage law for the circuit is shown here. This circuit is drawn by converting the values using the uh, using the force voltage analogous values. That is, we have to change these value in terms of this electrical element here. After that, we are getting L1 into di1 divided by dt plus R1 into I1 plus R12 into I1 minus of I2 plus 1 by C1 into integral of I1 minus of I2 into dt equal E of t. L2 into di2 divided by dt plus R2 I2 plus R12 into I2 minus of I1 plus 1 by C1 into integral of I2 minus of I1 dt equal 0. Now we are going to draw a equations we are going to draw a diagram through this equation. Okay, so here we are going to use the mesh value, that is mesh types of Kirchhoff voltage here. So for we are considering the mesh value, means we are considering the loop for I1 first and considering the loop for I2 second. A common value of I1 and I2s are drawn in between the loop I1 and I2, and the other values are connected in series across the series in the diagram. Okay, so a common value here is the resistance, that is R12, and the capacitance C1 here. So we are going to draw the R12 and C1 in between the loop I1 and I2. After that we have to draw a element which belongs to I1 in the one side and which belongs to I2 in the another side. Every elements are connected in series here. Okay, so we from using that we have drawn the force voltage circuit. Now we are going to draw a force current analogous circuit. For that we have to change the analogous element for the element of a mechanical system, that is force will be considered as the current and the mass will be considered as the capacitor and the friction will be considered as the reciprocal of the resistance and the spring will be considered as the reciprocal of the inductance, and here the velocity will be considered as the voltage. So using this substitution we get C1 into dV1 divided by dt plus 1 divided by R1 V1 plus 1 divided by R12 of V1 minus of V2 plus 1 divided by L1 into integral of V1 minus of V2 dt equal I of t. C2 into dV2 divided by dt plus 1 divided by R2 into V2, 1 divided by R1 of 2, V2 minus of V1 plus 1 divided by L2 into integral of V2 dt plus 1 divided by L1 into V2 minus of V1 into dt equals 0. Okay, in for a force current analogous system we have to use a node based equation, and we have to write the we have to draw the diagram in the form of node base. So here we have considered the voltage V1 as node 1 and voltage V2 as node 2. In between that we have to draw a diagram that will be common for V1 and V2, that will be connected in parallel. Okay, so then here we are having the R12 and L1 value is common for the V1 and V2, so that will be drawn in the center of V1 and V2, that will be drawn in between the V1 and V2 in a parallel manner. Okay, after that a values belongs to V1 is connected in the parallel manner here. After that V2 will be connected in the parallel manner here. Okay, these are the in this types we are going to draw a force voltage and force current analogous systems. Okay, thanks for watching this video. Thank you.